Let's start with the domain of number 3. So from left to right, here we go. This arrow means it will continue to go to the left to negative infinity. And as I go here, and you're welcome to use a blank piece of paper tomorrow that I will provide, the entire way we see some part of the graph. Even at this point, the open circle means that there's a hole in the graph, but we can see above it, we actually have part of the graph. Here's where we have part of the graph. Here's a hole in the graph the entire way. So how do I show that the entire way exists? Negative infinity to positive. Okay, now let's look at this from left to right. You're going on a road. Are you going uphill or downhill here? Downhill. I'm just going to put a D for decreasing. Now this middle section, you're going up or down. You're staying constant. And then the last piece, you're going up or increasing. So right away, I'm going to come over here and I'm going to make brackets. Notice that problem 3 does not, excuse me, I meant to say parentheses. Problem 3 does not provide the brackets or parentheses. You have to know that increasing, decreasing, and constant only ever use parentheses. Let's go back and only look at this. If I'm describing this decreasing, when I say it comes from the far left, what symbol do I use, far left? Negative infinity. So I'm going to decreasing, there's negative infinity. And it comes all the way to an x value of negative 2. Don't worry about that being an open or a closed circle because we know we're only using parentheses. Let's do constant. It starts at negative 2 and it goes all the way to an x value of 3. And lastly, increasing. It starts at 3 and as it moves to the right, it will continue to increase. We're going to move on to what most people think is the most difficult part of this. And what the heck does this mean? We're going to identify, if they exist, what are the intervals where the function is positive. So this means where are there intervals where the y values are positive and where are there intervals where the y values are negative. So I went ahead and I took a highlighter. This is like the divider. Anything above that, y's are positive. Anything below that, y's are negative. And this is neutral. This is where y's are equal to 0. So positive, negative, and 0. So let's look at this particular graph. This section is all in the positive. This section is in the positive, and this section is the positive. We can see that right here at the x-axis we have a hole, so we need to keep that into account. So let's get started. I have 3 different sections in the positive. I have no sections in the negative. So I'm going to come down here and write NA. There is no intervals that are in the negative. Okay, you ready? Let's look at this part right now. When we describe it, we don't just use parentheses. With f of x, when we describe it being positive and negative intervals, we have to consider sometimes we'll use a bracket, and we'll look at one of those incidents. So it comes from the far left, this piece comes from the far left, negative infinity, and all the way up to an x value of negative 2. Now turn to your partner. Should this be a parenthesis or should this be a bracket based on what you see? Go to your partner. So my question is, on this piece, right here, where you see a hole, at this piece where x equals negative 2 for this piece, would this piece be in the positive section? I can see where you'd be like, yeah, it's above the x-axis, but there's a hole there. So we need to say there's not actually even a point there. That's why there's a hole. That's why we have a parenthesis. If it was closed in with a dot, we'd put a bracket. Okay, the next part goes from x equals negative 2 to x equals positive 3. Please turn to your partner. Do I use parentheses or brackets? We use brackets. Why? It's in the positive region and we have a closed dot. Let's go to the last piece. It starts at 3 and as it goes to the right, it continues to be in the positive region. Now there's a couple different reasons why I'm going to use a parenthesis here. One, it starts on the x-axis, and also we can see that it has a circle or a hole. I would think these are the easiest parts for you to get right. So let's go over this next part. What does this mean? This is function notation. It means go to where x equals negative 8. So I find negative 8. Here's 5, 6, 7, 8. I go straight up or down until I actually hit the graph. And all I'm going to do is look at what is the corresponding y value. It looks like it's exactly 4. I go to where x equals negative 1, which is right here. I go straight up. The y value is 3. I go to positive 3, and you may be tricked here. Is it the top one or the bottom one? Bottom one. Please turn to your partner. Is the top one or bottom one that's a part of the function? The top one because it has a closed dot. What's that y value? 3. Okay, turn to your partner. You're ahead of me right now. What symbols should we put into these two places for this particular function? Go ahead. As I go to the far left, let's describe the behavior. As I go to the far left, let's describe the behavior. It is headed up. It is headed up, which is positive infinity. As I go to the far right, it is headed up, which is positive infinity. Okay, the y-intercept here is 0, 3. Now the rate of change. I would like you and your partner to do it graphically or algebraically, whatever is easier for both of you. Go ahead. All right, so here we go. I'm going to do it graphically. I want to know what's happening here. Well, I can predict it's going to be a positive value because it's going up. It's going up 1, 2, 3, 4, 5. I just went up 5, plus 5. Why is it positive? Because I went up. Then 1, 2, 3, 4, 5, to the right 5. You can leave it as 5 over 5, or you could put 1.